Okay, example 4. The Northern Manitoba Trappers Festival, held in the past, originated in 1916. A championship dog race has always been a significant part of the festivities. In the early days, a race was non-stop from the pass to Flin Flon and then back. In one particular race, the total distance was 140 miles, and conditions were excellent on the way to Flin Flon. However, bad weather caused the winner's average speed to decrease by 6 miles per hour on the return trip. The total time for the trip was 8.5 hours. What was the winning dog team's average speed on the way to Flin Flon? Okay, so this is one of those questions where we're talking about speed, distance, and time. And from like Science 10, you probably have speed is equal to distance divided by time, or possibly your teacher used a V for velocity. Okay, we are going to be probably talking about the scalar version versus the vector version. Okay, so scalar means that we're just going to look at the distance there, the distance back. We would kind of add those things together if we had to do a total distance. We do have two parts of this trip. We have the there part and the back part. Okay, now what they told you was, and most of the time you're going to rearrange this, because what they told you is a relationship of the two times. Okay, yes, they did relate the two speeds, but they related the two times by saying, I know that if I have this time plus this time, it should equal this. So you've related both of them and you have the equal sign with this. So what we need is the time there, so T1, plus the time back, I'm going to call that T2, and that should equal 8.5. Okay, or what's another way to write 8.5 if I need a fraction? (17 over 2). Is that right? Is that 8.5? Yeah, because 16 over 2 would be 8, and then the other half, okay, 17 over 2. All right, so we have to rearrange this formula. Speed is distance divided by time, and you almost always rearrange that the same way for in math, because you're just going to switch those two. So your time would be your distance over your speed. So this is something you might want to put on your formula sheet, is how you're going to convert this here to that there. It's really, really common question. So distance over speed is going to equal your time. So what we have is we need the distance there over the speed there, and then this one's on the way back. So the distance back over the speed back, and that should equal 17 over 2. Now some of these, I have way too many variables here. I actually have 4 different variables. I got a D1, a D2, an S1, and S2. But some of them we can actually put values in, and others we can relate them. So what they did here was they gave you information about the total distance was 140 miles. Well, if you're going there and back, then there should be the same amount as coming back, and they'd each be 70. So I know that my distances are both going to be 70. Okay, now the speed, I just want to get this down to be one variable. So they've related the speed for me. So I can let S be, or X, it's up to you, S be the speed on the way there. And then what would the speed on the way back be? Well, it's decreased by 6 miles per hour. So it's going to be my S minus 6. Okay, sometimes I don't like using S's because they look like 5s. So that's when I'll use a V or an X or something like that. Okay, give me a nod if you're okay with how I got this question. Okay, perfect. So now these are just the same as before. We have adding and subtraction of rational expressions, but there is the equal sign. So I can start to, I have to make sure my denominators are factored, but they already are. Okay, and I'm just going to start to multiply the top of everything by each of these. So this is going to get multiplied by S, S, S. And it's also going to get multiplied by S minus 6, S minus 6, S minus 6. And also everything is going to get a 2. I'm just going to squeeze my 2 in front of my S here. Okay? So on this one, the S's cancel. And what I'm left with is 70 times 2 times by my S minus 6. On the second one, the S minus 6 cancels. So I'm left with 70 times by 2s, or 70 times 2 times s, okay, Equal sign stays in the same spot, as does my addition symbol or whatever symbol's there. Okay, and then this one, the 2's cancel. So what I'm left with is a 17 with an S minus 6. Okay, this will end up being a quadratic, but it doesn't look like one just yet because I have all my brackets. But I did need to factor it first to cancel my denominators. But now that I've canceled my denominators, I can multiply all these things back out. This is technically how much? 140. Good. So I want you to imagine that you have 140 and you're distributed into both of these. This would be 140s minus, what's 140 times 6? Does anybody have that one? 840. Good. And it's a minus 840. Okay, plus, this one's kind of easy. 70 times 2s is 140s. Okay, and on the other side again, these are monomials right here and here. So I kind of think of them already as one item, and I'm going to multiply them out. So I have a 17s there, and I'm distributing it to an s minus 6. So it'll be a 17s squared minus, and I have down that this is 102. Minus 102s. Okay, I'll give you a minute to write that down. Raise your hand if you got a question. Okay, so now it's quadratic, but it's kind of all over the place. We can only solve quadratics if we set them equal to 0. So I'm going to move everything to the right side so that my s squared stay positive. Okay, these two together here are 280s. So what's going to, 280s. So I'm going to minus that over to the other side. And this one stays here. And if I minus that over, I get negative 382s. And then I also need to add my 840 over to the other side. Okay, these are huge numbers, and 17 is a prime number, so it doesn't factor nicely, so it doesn't, there's no greatest common factor that comes out. And these are huge numbers that I probably don't want to make a factor list for. So just because, even if it was factorable, I don't have to factor it unless it says solve by factoring. Which, now it won't say that. That was chapter 4. Now it'll just say solve. So you can pick any way you want. I probably would use the quadratic formula in this case. Okay? So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And here's your a, this is your b, this is your c. You don't have to memorize this, it's on your formula sheet. So a negative b would be a negative of a negative 382, so that's going to end up being a positive. Plus or minus the square root. Don't forget, when you put this b squared in here, you need to make sure you put the negative in brackets, or else you'll come up with a negative answer for that piece, and you need it to be positive. So minus 4 times by a times by c. And then in the bottom, it's over 2 times a. Okay, we haven't done this a lot lately, so what I'm going to do is I'm going to have you take out your calculators, and I want you to tell me what is under the square root. If you're somebody that struggles with this, do the first piece and then do the second piece and then subtract them if you need to. You could do that separately, or you could put it all as one big piece under there. But you got to make sure you use the brackets properly. Does anybody get the final answer underneath there? It's huge. Good. 88,804. Okay? So that's the negative 382 squared should be a positive number. Then the 7 times 14 times 840 is another positive number, but you're subtracting them from each other. So that's why it ends up being 88,840 or 804. Okay? Now, is this a perfect square? So try to square root that. Do you actually get an answer? 298. Good. So you know what that tells me? It was actually factorable. So I could have spent the time to find the factor pair that worked. But as you can see, as long as you punch this into your calculator correctly, you're still going to get the same answer, and you didn't have to find that factor pair. Okay, so you can add these together, so you can get a minus answer. If you minus them, you can get the answer that if you plus them. And then don't forget to divide by 34 after you've either added them or after you've subtracted them. Okay, what are your two answers? One's going to be a nice whole number. One will be a fraction. I think the minus one ends up being a fraction. It doesn't end up being a negative number, which is okay. So what do you get as a fraction for the minus one? 42 over 7, which is actually how much time? 17. Over 17? Okay, which is actually how much time if you had to round it? So what is 42 divided by 17? 2.4, blah, 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 blah. Okay, what's the answer when you add them? 20, good. Okay, so usually we have an extraneous root because our time ends up being negative. Do we have a time that's negative here? No. But we do have an extraneous root. Can anybody tell me why? Go ahead, yeah. Right? That's true. Is there another reason why? So, just for the video, the 2.4 doesn't seem logical because if you were going that slow, you wouldn't get it done in 8.5 hours, right? But is there another reason why 2.4 is the extraneous root? What did we solve for here? The speed there or the speed back? So, there was a speed there, right? So, how do you find the speed back? You have to go back up here, and the speed on the way back was s minus 6. Can you take 6 away from 2.4? No, you can't, because you get a negative. Remember, I said we're going to be talking about scalars, not vectors. So this is extraneous, logically, of course, but also because, in mathematical terms, it makes the speed back negative. Okay, and that's similar to those questions that we've done where you do the length and width, and when you figure what x is, and then you plug it back in, if one of your sides ends up being negative, then it's the extraneous root.